Fifth grade Excel, lesson 37. We're going to be looking at the true and not true number sentences, correct symbol for number sentences, and using trial and error, or what I call guess and check, to replace unknowns in an equation. Alright, let's take a look at this first part here. Number 1, 4 equals 4 is a true statement because 4 is equal to 4. 3 equals 5 is not a true statement because 3 is not equal to 5. 6 is not equal to 6 is not a true statement because 6 is equal to 6. And let me add that 7 is not equal to 6 is a true statement because 7 and 6 are not equal to each other, so that is true. These are some of the trickiest for kids. They don't even mention that in here, unfortunately, but yeah, these do throw kids off because they see the not true sign, or the not equal sign, and so they write not true every single time, even when this is true. 7 is not equal to 6. If you are having trouble with the not equal symbol, put your finger over the symbol and then decide which symbol is correct, either equal or not equal. If the correct symbol is there, the statement is true. Otherwise, the statement is not true, and that's good advice. So what we're going to do is show our work like usual on these. Number 4, they show you 7 times 3 is not equal to 4 times 5. I need to see your show work, so everybody write 21 up here and write 20 up here. So you cover up this with your finger right there, cover up that symbol, and you ask what symbol would go in there, equal or not equal. 21 and 20, are those equal or are they not equal? Well, they're not equal to each other. So look what they wrote. They wrote not equal. So that's a true sentence, true statement. So you'd write a T for true. On these type of problems, you're going to write either T or NT. T for true, NT for not true. All right, go ahead and pause the video, do 5 and 6, turn it back on when you're ready to see the solution. 2 times 5, you should have shown your work by putting 10. 9 times 1, 9. 10 is smaller than, less than 9. That's not true. 10 is actually greater than 9. So we're going to say not true on that one. The next one, you should have put a 13 here and a 12 here. 13 is greater than 12. Yes, 13 is the bigger number, so we'd say that this is true. The symbol that separates the two sides of this statement is missing. Combine the numbers on each side and then select the symbol that will make them a true statement. So we have to actually pick the symbol that goes in here, either equal, less than, or greater than. Always show your work. So we'll do this first one together. Write a 7 here, a 6 there. What's bigger, 7 or 6? Obviously the 7, so we have to have the bigger side of the symbol pointing to the bigger number. All right, pause the video, do 8 and 9, turn it back on when you're ready to see the solutions. Here you should have written a 12, and here you should have written a 12 because they both come out to be 12 with an equal symbol. 9 minus 3 is 6, 8 minus 1 is 7, so you should have written the symbol that shows the 7 bigger than the 6. That's called a less than sign. All right, did I skip a page? No, okay. Now what we're going to do is this little trial and error, guess and check type of problem. And we're going to see problems that have 2 missing numbers in them. When you see that, you're going to have to just guess what number would fit and check and see if it works. And these do really throw kids off sometimes because they assume that their answer comes out the same, but it doesn't. So you got to really watch out for these. So what we're going to do, like on this problem here, n times 4 equals 6 plus n. You just start with the number 0 and you plug it in for n and see how it comes out. When I put a 0 in here and a 0 in here, 0 times 4 is equal to 0. 6 plus 0 is equal to 6. 0 equals 6? 0 does not work on that problem. Let me go ahead and get rid of that. So then we try a 1 on both sides. 1 times 4 is 4. 6 plus 1 is 7. Is 4 equal to 7? Nope, that doesn't work as well. Now you probably want to do these in your head until you find the right answer. You're going through an order though. Always start with 0 and work your way up. 2 times 4, well that's equal to 8. 6 plus 2, that's also equal to 8. And 8 is equal to 8, so the n is equal to a 2. All right, let's take a look at another sample problem before we go on. N times 7 equals 12 plus n. First let's try 0. 0 times 7, that's equal to 0. 12 plus 0, that's equal to 12. 0 doesn't work. How about 1? 1 times 7 is equal to 1. 12 plus 1 is equal to 13. 7 over here. 7 is not equal to 13, so 1 doesn't work. All right, how about 2? 2 times 7, that's 14. 12 plus 2 is 14. Hey, that works. 14 equals 14 when I plug the number 2 in for each n. So n is equal to 2 again. That's just a coincidence. All right, go ahead and try numbers 11 and 12. Pause the video, turn it back on when you're ready to see the solutions. This one says x times 5 is equal to x plus 0. Let's try 0 first. 0 times 5 is 0. 0 plus 0 is 0. Look at that. When you plug in a 0, it works right away. And so you just say x is equal to 0. 9 plus b equals b times 4. Well, let's start with 0 on both sides. 9 plus 0 is equal to 9. 0 times 4 is equal to 0. Is 9 equal to 0? Nah, that doesn't work. Okay, how about 1? 9 plus 1 is 10. 1 times 4 is 4. 10 is not equal to 4, so that's not going to work. This is getting kind of messy. Let me erase this. And again, I would not write any of this stuff down until you find the right answer. I'm just showing it to you what I'm doing mentally in my head so you can see it on your screen. Then I try a 2. How about a 2 in here? 9 plus 2, that's 11. 2 times 4 is 8. 11 and 8 not equal to each other. How about a 3? 9 plus 3 is 12. 3 times 4, hey, there we go. When I plug in a 3, 9 plus 3, 12. 3 times 4, 12. So b is equal to 3. And that's what you should have gotten on that problem right there. All right, so that's it. Thanks for watching.